Hello, my name is Guillermo Rodriguez and I'm a principal architect with Presidio, specializing in VMC on AWS. And joining me is Wilson. And we're going to be talking about NSX, specifically software-defined networking and how you can use it to help take your current environments, your applications, your solutions, and take them to the next level. So before we get too deep into NSX, I think it's important to understand what is a software-defined data center and how you are likely already starting to use some of those technologies today. So as it stands today, more than likely you're using some level of virtualization. Typically it's going to be virtualization of the compute stack, so your CPU and your RAM. And what that has done for you is it allows you to abstract your applications and your operating systems from the physical hardware. And likely you have leveraged some of that to move your virtual machines from host to host, create more resilient and highly available environments. That same concept is what software-defined networking and specifically NSX does, but when it starts to apply itself to a lot of the networking components that you're familiar with today. For example, in your data center, you likely have several physical components such as firewalls, load balancers, routers, all of this other equipment that is inhabiting your racks. All of those pieces of equipment have some kind of firmware on them. If you want additional features, you have to upgrade that firmware and go through some kind of a maintenance cycle. In some cases, you may want to take advantage of new features, but the hardware you currently have today doesn't have the ability to upgrade to the latest and greatest. Now you have to switch out hardware, and it gets very disruptive to your data center environment. NSX changes that game because now you can take a lot of those functions that you would normally offload to these other pieces of physical equipment and bring it down into the hypervisor environment and gain a lot of optimizations and a lot more control over how you use the networking stack today. So some of the features that we're talking about here specifically is, for example, VLANs. VLANs today is the ability to distribute and kind of carve up your environment, and they're limited. So you typically have about 4,096. It's a little bit less than that, but that's the limit that you have today for those for the number that you can create. As your data centers grow, it may sound like a lot, but eventually it becomes very limiting. One of the things that NSX does, especially with Geneve, is it lets you have logical segments of over 4 million. So really, it's definitely not an infinite number, but it gives you a lot more flexibility and opens up the ability to get your applications and really tighten up how they communicate with each other, partition off certain pieces, and just make things a lot more granular. With that, you can also layer on some security. So you do have things like, for example, the distributed firewall. The distributed firewall is effectively a zero trust model. It places a firewall in front of every virtual machine in your environment, and you can set up rules to very tightly control all of the traffic that goes in and out of your virtual machines. That kind of sounds like a little bit of a nightmare, because imagine having to manage all those firewalls to get the job done. But the distributed firewall allows you to write very specific rules around how you control those VMs. You can write your rules based off of the logical segment they inhabit. You can write those rules based on the naming convention. If you have a very solid naming convention, you can specify very explicit behaviors for any virtual machine that contains the word web or DB. You can also employ tags to your environments and place specific rules around those as well. So that way, you don't have to configure every new virtual machine you deploy. You effectively set up profiles, and any new virtual machines that you deploy either via their naming convention, the segment they're deployed in, Or by applying specific tags to get certain behaviors, you can change what access they have and really control whether or not certain systems can or cannot communicate with other components of your network. Automation is another huge capability here in that the entire environment is API accessible. So if you are automating the deployment of your virtual machines, of your application stacks, and are limited by being unable to do that with your networking stack, now you can have that ability. So you can go ahead and create the necessary logical segments and firewall rules and deploy the appropriate routing for those applications as part of the deployment. Obviously, this limits, or better said, it reduces the amount of time it takes for your teams to get these applications up and running. Also, there's optimizations to consider here too in just the architecture of it, because a lot of what we're talking about here is getting these virtual machines to communicate inside the hypervisor versus what is traditionally happening today is you have a virtual machine that is on one segment, and then you have another virtual machine that is on a different one. And all that traffic between those two virtual machines typically has to exit the hypervisor, go to the switch, pop through the firewall, and then the firewall is going to make its decision about whether that is or is not valid traffic. It then finally goes to the virtual machine. It's inefficient in many cases because sometimes those two virtual machines are literally on the same physical hypervisor. A lot of the routing and firewall actions are actually in the kernel. So these decisions can happen inside the hypervisor and they don't need to leave the hypervisor. So with some careful grouping of your VMs and leveraging this technology, you can really reduce the latency and a lot of the congestion that may be present on the overlay networks that you currently have deployed. All in all, we're looking at some of the real base features and optimizations that you can gain with NSX. I would love to have a broader conversation if any of this sounds interesting to you, or if you think that you want to take things to the next level and start pushing this out into not just your on-premise data center, but all of the clouds out there have the ability to do this as well. So whether you're looking at VMC and AWS or Azure VMware solutions, this is all leveraging these kinds of technologies, and you can bring those into your on-premise deployments as well. So I really hope that you found some of this informative. And again, I would love to have a continuing conversation around this if any of this interests you. And thank you very much for your time, and hopefully you'll follow Wilson around the island as well, and have a great day.